Okay, so the starting point for this is that I have some data where I did 100 trials of a 2D experiment. So we can tell it's 2D. If we look in the C column, we can see all the y distances and they're not 0. So what we have to deal with, like we did in the 1D, is that we have a dependent variable, which is the movement time. We got that right here. That's great. So it's in the F column already. But then we have the independent variable, the index of difficulty. It depends on the distance and the width, the target size. The problem in 2D is that if we're moving from a low point on the screen to a high point on the screen, the distance depends on both the x values and the y values. Likewise, the target size doesn't just depend on the width, which is the size in y, but it also might depend on the height. The target size could be the distance across there. And so in 2 dimensions, we need to take both of those things into account. The easiest thing we can do is to use the Pythagorean Theorem. For more extra credit, you can be a little more sophisticated than that. What I'll show you how to do in this demo is to take the x and the y distances and turn them into the straight line distance between the starting point and the ending point. And I'll also show you how to take the width and the height and turn that into a target size. So I'm going to make a column called distance. I'm going to make a column called size. And I'm going to turn those into the index of difficulty. That's our independent variable. The movement time, our dependent variable, is just the column F that we've measured before. So just like we did with the 1D case, that part's pretty easy. So to calculate the distance, we want to think of it, Pythagorean theorem, as the square root of the x distance squared plus the y distance squared. So start with the plus or whatever symbol you want to use to tell Excel that you're going to make a formula. Don't do the good habit of actually closing your parentheses like programmers do, because Microsoft is too stupid to understand that. So now what we want to do is we want to take the x distance, which is in row B, in column B, we're row 2 here, and we want to square that. There's 2 ways to do that, but squaring it, if we want to keep it very simple, just means we're multiplying it by itself. So B2 star B2 in this case. And then we're going to add to it the y distance, which is row 2 of column C in this case, and star itself. So C2 star C2. So that gives us in pixels the distance that we need. If we want to do the same thing in the size column, what we need to do is we need to take the square root, and it's not distances, but it's of the width and of the height. So I'm going to be smart. I'm not going to close parentheses yet. But the width is column D, so multiply it times itself, plus the height in column E. And if we want to be a little clever, if we don't just want to multiply it by itself, we can use the caret symbol and raise it to the second power. That's what we mean by squaring. So either one of those works. They're interchangeable. So now we have the distance and we have the size. If we want to get the index of difficulty, what we did in 1D was it was the log. It's going to be base 2. It was the distance divided by the size. In 1D it was the x distance divided by the width. In 2D is just our distance, which we have in column H, divided by the size, which I happen to have in column I. Add 1 to it for the index of difficulty, base 2. Okay, now we're done. We have one row. I can copy and paste it for the other 99 rows. And so now we're in known territory. It's a little bit more annoying than 1D. The columns we need aren't automatically highlit now. We had some extra columns highlit. We could have been clever and we could have made that work. But now I have 2 columns highlit. J in this case is my independent variable, K is my dependent. So now I can go and add a scatter plot, select the data, right click, add a linear trend line, display the equation. This is what I end up with. So one thing you'll notice is the 2D data doesn't fit on the line as well as the 1D. Fitts law gets murkier and murkier when you take it into stranger territories. That's an active research topic. What you can do for more extra credit is you can try to come up with better estimates for the target size, and if you do good, if you find better estimates, you'll probably find that this fits on a line better. Anyway, this is what we see in 2D. 240 milliseconds for the activation time, 186 milliseconds for the time to cover an index of difficulty.